Welcome, Math 3. In this video, I will be talking about the volume in these questions. It asks us to change a certain length of the object and seeing how it affects the volume and what can we do to keep the volume the same. The first problem asks us to look at a cylinder, and we are looking for the volume of a cylinder here. So let's first write down the volume of a cylinder. The volume of a cylinder can be defined by V is equal to the base area, which is pi r squared times height. Then we'll see what happens when the radius was twice the size. So what I'm going to do here is make this I, because this is the initial height. Nothing happens to it. Then the new volume will be pi r squared times and height, but the new radius is doubled, so we can put 2r here. Okay, what that does is 2 squared becomes a 4, leaving you with pi r squared times height. But notice this is just the original. So this is just 4 times the original volume. So what you can say here is that the final volume is 4 times the initial volume. But take a look. We want to keep the volume the same. So to keep it the same, you would have to divide by 4 to the other side. Okay? Here, it's kept the same. Okay? So to keep it the same, there is a division of 4 that happens. So what would the height be if the radius was twice the size? So to keep it the same, okay, this is what we have to introduce to the height. The height would have to be divided by 4. Do you see that? Because of this is really 1 divided by 4. So that's what happens that you need to do to the height. You would have to divide by 4. Okay? Next problem. What would you do if the radius, what would the radius be if the height was cut in half? Right? Same process as before. So let me just grab this equation. And we know that our final volume, which is going to be VF, is going to be pi r squared, but the height is now going to be multiplied by 1/2. All right, let me give you some room. Okay, I'm just gonna move that 1/2 in front, so it's 1/2, leaving you with pi r squared times height. But again, this is just VI. So VF, which is the final volume, is going to be equal to 1/2 the initial volume, VI. So what do you need to do to the radius in that sense? So to counteract the 1/2, you would have to multiply it by 2, multiplied by 2. So you can say that you're multiplying the final volume by 2 to keep VI the same. Okay? So what does that mean in terms of the radius? So here's the radius. Okay? And remember, it is r squared. So I can just write it here. It's r squared. What you want to do is you want to multiply that by 2. Okay? But you want only one of the r. So what you have to do is square root it. Okay, so what you need to do with the r is you have to square root it. So to keep it the same, to keep this the same, if you are going to half the height, you have to multiply the radius by the square root of 2. Okay. Now, this question for 5 is done the same exact way. The formula just changes. It becomes 1/3 pi r squared times height. Okay, but the answers are exactly the same because you're just multiplying it by 1/3, but the answers remain the same. So the answer for 3a and b is the same answer as 5a and b. Okay, there you go.